This is a metal planet baked by the sun. Surface temperatures can melt lead and tin. Yet, incredibly, it still has polar ice caps. This is Mercury. Mercury is the smallest planet in our solar system. Its diameter is just 4,879 kilometers. That's smaller than some moons of Jupiter and Saturn. Its average distance from the Sun? Only 58 million kilometers. This close proximity creates extreme temperatures. Mercury's sun-facing side reaches 427 degrees Celsius. The dark side plunges to negative 179 degrees Celsius. The day-night temperature difference? Over 600 degrees Celsius. Despite being such a hellish world, humans explored it. We've launched 3 groundbreaking missions: Mariner 10 in 1974, Messenger in 2004, and BepiColombo in 2018. Here in 2025, BepiColombo is still exploring Mercury. Today, let's dive into Mercury's complete story. Friends, towards the birth of Mercury. About 4.5 billion years ago, our solar system began forming. It started as a rotating disk of gas and dust. We call this a protoplanetary disk. This disk contained hydrogen, helium, and heavier elements. These came from supernova explosions and stellar evolution. Tiny dust particles gradually clumped together. They used electrostatic forces and collisions. Particles grew larger and larger. Then they became kilometer-sized bodies called planetesimals. Over time, planetesimals attracted each other. Gravity pulled them together. They merged into even larger bodies called protoplanets. This is how Mercury slowly formed. It experienced violent impacts and melting processes. These increased its mass and caused core differentiation. Mercury formed as one of the innermost planets. The sun's intense gravity and radiation influenced it heavily. Being so close to the sun created extreme heat. This heat caused hydrogen to evaporate and escape. Volatile materials also escaped. This is why Mercury has such a massive metallic core. The core comprises over 1/3 of the planet. That's about 42% of Mercury's total mass. Earth's core is only 19% by comparison. Mercury's core is primarily iron and nickel. This gives it a magnetic field. Despite being tiny, Mercury has enough magnetism. It can protect its surface from solar wind. It even maintains an extremely thin atmosphere. Ancient observations. Ancient Babylonians observed Mercury as early as 3000 BCE. They called it Nabu. Through careful observation, they tracked its periodic motion. They could accurately predict when Mercury would appear. They also predicted where it would show up. Historical records of Mercury go way back. Ancient astronomical texts mention it frequently. Mercury stays close to the sun in our sky. It's only visible from Earth briefly at dawn or dusk. Mercury's unique rotation. Modern scientists made an interesting discovery. Mercury's rotation period is about 58.6 Earth days. Its orbital period is about 88 Earth days. Mercury's rotation is 2/3 of its orbital period. This means something fascinating happens. Mercury rotates 3 times while orbiting twice. This relationship is called orbital resonance. It results from the sun's tidal forces. These forces interact with Mercury's internal structure. Due to this special resonance, something amazing occurs. One solar day on Mercury lasts 176 Earth days. That means one Mercury day equals 2 Mercury years. Scientists aren't entirely sure why Mercury rotates so slowly, but they suspect it's been this way since birth. The Mariner 10 mission. On November 3rd, 1973, NASA launched Mariner 10. It was the final probe in the Mariner series. More importantly, it was humanity's first Mercury explorer. Its primary mission was to study Venus and Mercury. It was also the first spacecraft to use gravity assist. Using Venus's gravity, Mariner 10 reached Mercury. It first flew by Mercury on March 29, 1974. Then it made 2 more passes, September 21, 1974, and March 16, 1975. The closest approach came within 700 kilometers. Key discoveries. Photography. Mariner 10 captured over 2,700 images. These were high-resolution shots of Mercury's surface. They covered 45% of Mercury's total surface area. Here's a fun quiz, friends. Can you guess which photo shows Mercury and which one shows our moon? Surprise? Both of those were actually the moon. This is Mercury. Mercury and the moon's surfaces look incredibly similar. Magnetic field. Data revealed something unexpected. Mercury has a magnetic field. It's about 1% as strong as Earth's. This surprised scientists completely. They didn't expect such a small planet to have magnetism. Thin atmosphere. Mercury has an extremely thin atmosphere. It's composed mainly of helium, hydrogen, oxygen, and sodium. Thanks to its large metallic core, it resists solar wind. It can maintain this wispy atmosphere. Massive core. Gravitational measurements confirmed it. Mercury has an enormous metallic core. We explained the reasons earlier. Mariner 10 was powered by 2 large solar panels. But after its final solar orbit in March 1975, disaster struck. It suddenly lost contact with Earth. It might still be orbiting the Sun today. The Messenger mission NASA wanted to explore Mercury further, so they launched Messenger on August 3, 2004. This mission had ambitious goals: study Mercury's chemical composition in detail, analyze its geological activity and magnetic field sources. The plan included long-term orbital observation. Messenger successfully reached Mercury orbit. This happened on March 18, 2011. During its mission, it captured 289,000 photos. This gave NASA the first complete surface imagery. They created nearly complete color maps. Major discoveries: polar ice. Messenger discovered ice caps at Mercury's poles. It also found giant impact craters there. Surface chemistry. Analysis revealed interesting compositions. Mercury's surface contains 46% oxygen, 12% magnesium, 26% silicon, 7% aluminum, and 4% calcium. Surprisingly, it found abundant sulfur, but very little iron on the surface. Volcanic activity. This created a surface composition puzzle. Why so little surface iron, but a massive iron core? Messenger solved this when it photographed ancient volcanoes. Scientists concluded Mercury experienced intense volcanism. The entire planet was possibly covered in lava. During this geological activity, heavy elements sank down. Elements like iron moved toward the core. Solar wind blew away volatile and lighter elements. Only small amounts remained in the atmosphere. Water discovery. Despite extreme heat on the sun-facing side, Messenger found ice caps in polar regions. These areas aren't directly illuminated by sunlight. The ice deposits are tens of meters thick. There might be ice water mixtures at the bottom. This increased speculation about underground water. In April 2015, Messenger's fuel ran low. It had flown for nearly 10 years. Scientists decided to crash it into Mercury. They wanted one final data collection. Messenger transmitted its last data set. Then it impacted Mercury's surface. BepiColombo mission. In 2018, a joint mission launched. The European Space Agency and Japan teamed up. They launched BepiColombo for close-range reconnaissance. This mission focuses on several key areas: Mercury's surface, magnetic field, and polar ice caps. It also studies Mercury's interactions with the Sun. The spacecraft is expected to reach Mercury orbit in 2025. We're writing this in April 2025. No specific progress updates have been released yet. Most likely, the probe is still traveling to Mercury. Let's eagerly await what secrets it will reveal. Mercury's surface. Features. Let's examine what Mariner 10 and Messenger discovered. Mercury's surface is almost entirely covered with impact craters. Some areas have smooth plains, though. This indicates Mercury was heavily bombarded after cooling. Currently, 567 confirmed craters have been identified. NASA named each one after historical figures. Scientists classify craters into 2 types based on morphology. Simple craters, usually 1 to 14 kilometers in diameter, they're less than 11 kilometers deep. These make up the majority of craters. They're mainly concentrated in the southern hemisphere. Complex craters, generally 16 to 270 kilometers in diameter. They're over 11 kilometers deep. Their distinctive feature is a central peak. This peak forms from rebound after impact. Mercury has the most complex craters in the solar system. About 110 complex craters exist there. Our moon has only 17 by comparison. The largest craters are better called basins. Mercury has famous basins like Caloris and Rembrandt. Caloris Basin. This is Mercury's largest crater. It's 1,550 kilometers in diameter. Photos suggest it was likely covered by lava. This gives it a smooth, bowl-like appearance. Rembrandt Basin. This is Mercury's second largest crater. It's about half the size of Caloris. Among all craters, scientists found the oldest basin. It's possibly over 4 billion years old. Thick volcanic ash covers its surface. It might hide secrets from our solar system's formation. Bonus discovery: Mercury's dust ring. Here's a final surprise for you guys. Around 2010, scientists made an accidental discovery. They were studying dust distribution near Mercury's orbit. They discovered a cosmic dust ring around Mercury. This ring is about 15 million kilometers in diameter. It consists mainly of fragmented asteroids. Cometary debris from solar system formation is also present. This discovery shattered previous theories. Scientists thought Mercury was too small for dust rings. They also thought it was too close to the Sun. This ring is incredibly thin. Scientists can only detect it through data analysis. Unlike Saturn and Jupiter's rings, Mercury's works differently. Its ring maintenance mechanism is more complex. Scientists speculate about undiscovered asteroid groups. Special gravitational effects might be involved too. These could counteract the Sun's dispersive forces. This discovery challenges traditional understanding. It reveals new possibilities for small body interactions. Its existence provides direct observational samples. We can study material remnants from early planetary formation. Wrapping up, you guys who love space exploration, this one's for you. Unsolved mysteries and cosmic stories await. Support Cosmic Canvas with likes and subscriptions. Your comments and subscriptions mean everything. They're the biggest support for Star Weaver. That's all for today's show. See you next time. Bye-bye.